All right, so here comes a problem 5. Problem 5 is about the owner of a boiler shop, and she's buying a component called a circulator from one of two companies. One company provides 60% of their circulators and has a .005 defect rate, and the second company provides 40% with a .01, and there's defect rate. And there's two questions. The questions are, what's the overall defect rate, in this case, in this admixture of two different types of circulators? And then, secondly, the question is, if a circulator comes up defective, what's the probability that it's from the first versus the second company? So, good problem. I think one thing about this problem is we ought to try to think about how to do it a couple of different ways. A couple of ways that are useful, in general, to work problems of this type. The first is what you're looking for is just the weighted average of these different circulators with different defect rates, where there's 60% of one and 40% of the other. And I actually prefer for you to think of that in terms of a frequency table, right? If we were just to summarize this problem statement. The problem statement says there's company 1 and there's company 2. And the defect rate associated with company 1 is 0.005, and the defect rate for company 2 is .010. And the frequency, and I'm going to call this instead the relative frequency, is 0.60 and 0.40. So if we were thinking of this in terms of a table, a frequency table, we would assign this the letter M and this the letter F. This being the frequency or relative frequency. It's not really the counts because it's divided by the total numbers here to give you a percentage which adds to 1. Yeah. And this being something like the midpoint. And then you might remember that the mean in this case is just the sum of the products of all the M's times all the F's divided by the sum of all the F's. And if I was just to write that down, that's this times this plus this times this. So it's 0.005 times 0.6 plus 0.01 times 0.4. Okay, and then the whole thing is divided by this sum, which is 1. So I'm just going to leave it like that. So we can do this, I think we can do this in our head. I think we can do this in our head. I'm not feeling like I can do this in my head all of a sudden. 0.005 enter 0.6 times, yeah. So if that's the case, this number is 0.003, this number is 0.004, the whole thing adds up to 0.007. So there's the overall defect rate. And you'll find that up in the answers to the problem. Now, the second problem said, if you find a boiler that is defective, what's the chance that it came from property 1 from property 2? So, another way to do these probability problems when nothing shows up except for percentages is to pick a number. Pick a number of boilers. Let's assume that there are 1,000 boilers. Not boilers, circulators. You know, boiler circulators. Okay, and then we can put numbers against this, right? Then we would write this up here as company 1 has provided 60% of 1,000 or 600 circulators, and it turns out 600 times 0.005 or 3 are defective. Yeah, And company 2 has provided 400 circulators. There's the total 1,000 circulators. And of those, 0.01 times 400, or 4, are defective. So if that's the case, consistent with this, if there are 1,000 circulators with this defect rate, then there are 7 that in total out of these 1,000. All right. And if I reach in here and ask what's my probability of pulling out a company 1, then the probability that things are coming from company 1 is 3/7, or 0.429. Often useful to go ahead when there's only percentages, to imagine some number, and it's usually 100 or it's 1,000 depending on the percentages, so that you can have a concrete number. And you can see this a little easier then, right? Since 3 of these circulators are from company 1 and there's a total of 7, the chances that it's from company 1 is 3/7. All right, you can find an answer up there. All right, let's move on. All right, welcome back. Problem 6 is back to confidence intervals, this time confidence intervals for proportions, population proportions. And I think I'd like to do problem 6 both by hand and by using the calculator, just to show you the difference and to review some of the fundamentals. So in this particular problem, there's a survey done at a state college of 100 students that were chosen as a simple random sample. And 78% said that they had changed their major. And the question is, what's a confidence interval then based on that of the percentage of students that changed their major, and you wanted a 95% confidence interval. So remember, confidence intervals are always the same thing. They are a point estimate minus, so this is the point estimate, and this is the margin of error. And they bound the point estimate. Well, actually, that's true. They do bound the point estimate. But what you're interested in here is the fact that you hope that they bound the population parameter that you're interested in, which in this case is the population proportion. So on the other side of this is p hat plus E. And then whether you're working with proportions or you're working with means, you'll find a different formula for the margin of error. In this case, this is Z alpha over 2 times the square root of p hat, q hat all over n. All right, and we'll work through those problems in just a second. So if you want to do this by hand, let's just note that from the problem statement, the sample proportion is 0.78. We want 95%, and so to find Z alpha over 2, we have to go to inverse norm. And we'll put in 0.025, 0, and 1 in order to find that. And then we calculated that before in the second problem. It's 1.9599. And if that's the case, Q hat is equal to 1 minus P hat is equal to, this case, 0.22, and N is equal to 100. So if I just throw all those in to this formula, E is equal to 1.9599 times the square root of, let me go ahead and put that square root sign in, the square root of P hat 0.78 times Q hat 0.22 divided by 100. Okay, so let me calculate that real quickly. I get 0.78 enter, 0.22 times 100 divide, take the square root of that guy, and I'm going to multiply him by 1.9599. 0.9599. And I'm going to get a number that I don't believe. So let me try that again. 2 times 100 divide square root. Yeah, that number I believe. 1.9599 times is equal to, well, let's say 0.081. Okay? So that means if I come over here, the confidence interval that I'm looking for is 0.78 minus 0.081, and it's 0.78 plus 0.081. And if I just calculate those real quickly, 0.699 and 0.78, 0.081 plus is 0.861. Let's say you can find that in the answers above. Let me very quickly here do this with the calculator. All right, so if I'm going to do this with the calculator, I've got to go to Stat and then swing over to Tests, and then swing over to 1-prop Z interval, which I have, there it is, down there, it's number A, which is 1-prop Z int. Okay, and when I select that, it's going to ask me a couple things. It says what's X and what's in. Well, you're not given X or in, you're given 78%. But what you are given in, you're given in as 100. And that means the number of successes in 100 has to be 78. The C level is 95.95. And that's all you have to do is enter those quantities, and you'll get the answer 0.699, 0.861, exactly what we got by hand. All right, you choose which of those two you would rather do. In a test situation, I believe I'd recommend using your calculator. All right.